Mister.
Hola, hola. Buenos días, buenos días, buenos días. O buenas tardes. Bueno, mis estimados, buenas tardes. Como que no queremos recibir clases, ¿verdad? Todo el mundo con la cámara apagada. Enciendan las muchachos, por favor. Enciendan esas cámaras. Ya solo quedan media hora y ya estuvo. Vamos. Gracias, Jorge. A ver, el resto the rest of the people, please turn on the camera, please. Come on. All right. Victoria, Efraín, Mila, María Fernanda, Agustín, Juan Matamoros, Pineda, please turn on the camera. Let me change uh, the video. Thank you. Yeah, I know in your case, Efraín, but the rest of the people, thank you. Thank you, Milan, Victoria, Agustín, Juan, Fernando, please turn on the camera, please. All right. Let me change the camera view. Let's going to put the pin my video and let's see. All right. Today we're going to continue with the solution of the problems from yesterday. The love of gases, or another way of saying, we were going to talking about according to the macroscopic description of ideal gas. Remember the different love of gases. We're talking about the law of Charles' law. The law of Charles, that means that pressure will be constant. The Boyle's law, that means that temperature will be constant. The Gay-Lussac, that means the volume will be constant. And the combined gas, there is no factor constant. And actually we have the ideal gas law. We're talking about according from for the quantity of moles, molecules, and how we went, what was the number of Avogadro's number. That's supposed to be 6.0323 times 10, and at the 23 power could be molecules, atoms, or particles. All right. Well, to summarize the situation, we're going to solve a couple of examples. The first one, we copied that already yesterday, but today we're going to do it again. In the first problem, it says that we have a 1 mole of oxygen gas. It's a pressure of 6 atmospheres and a temperature of 27 Celsius degrees. Letter A, if the gas is heating at constant volume, until the pressure triples, what is the final temperature? Is the first question. And the second one is the gas is heated so that the pressure and volume are double. What is the final temperature? Okay, let's do it. Just going to start with the problem. First of all, this is the keyword. In the part A, the problem mentioned this gas is a constant volume. Because this is gas, this is a constant volume, we can conclude in the part A, we're going to use the the Gay-Lussac law because we have a constant volume. It's so simple. What the values do we have in this situation? Well, first of all, we have the first value from the pressure. The pressure one will be 6 atmospheres. That temperature one, that will be 20 Celsius degrees. And remember the gas, the pressure of the gas will triples. That means the initial pressure will be multiplied by 3. That will be 18 atmospheres. So the question is, what will be the final temperature? I mean, the new temperature. Okay, before to do that, remember the first thing that we must to do is establish those values in the international system that we're looking for. In this case, remember the pressure must be set up in pascals and the temperature must be set up in kelvins. 6 atmospheres, remember 1 atmosphere, that will be 1.013 times 10 at the fifth power pascals. Okay, and same happened with the 18 atmospheres. Okay, 1.013 times 10 fifth power pascals, it has 1 atmosphere. Okay, this is going to be the first thing that we must do. And the temperature, remember to transform Celsius into Kelvin. The only thing that we have to do is adding that 27 Celsius degrees plus 273. And we're going to obtain Kelvins. Okay. So, in simple better words, 227 plus 273, the temperature will be 300 Kelvin. And that will be the initial temperature. Now, if we multiply 6 times 1.013 times 10 at the fifth power will be 607,800 pascals. And remember, the 18 times the same value, that will be 1,823,400 pascals. Okay. We have the units in pascals. We have the units in Kelvin degrees. Okay. Now, this is the moment of truth. What we're going to do? Simple. Just what we said, the Lussac law. Remember? Pressure 1 over temperature 1, that will be equal to the pressure 2 over the temperature 2. Because we are looking for the value from pressure 2, we can apply cross multiplication. I mean, P1 times T2, that will be equal to P2 times T1, cross multiplication. And because we're looking for T2, P1 is multiplying, passes to divide. I mean P2 T1 over P1. And that's it. That's all that we had to do. At the moment, we're going to apply the formula. So the pressure number 2 will be 1,823,400 pascals. Okay, multiplied by the initial temperature, that will be 300 kelvins degrees. And this equation divided by 607,800 pascals. Okay, as soon as you can see, we cancel pascal with pascals, and the new temperature, as a manner of speaking, will be 3 times that will be 900 Kelvin degrees. This is going to be the new temperature, at least in the part 8. Understood this part? Questions?
Yes, Mister.
Mhm.
Why do you pass it to pascals?
Because remember, in physics, we are working the unit of the pressures in pascals and the volume in cubic meters. In chemistry, we're working with atmospheres in chemistry. At least the problem requires the pressure must be set up in atmospheres. Now, this is the only reason, okay?
And the temperature?
The temperature is according for the situation, the temperature in the level was because the Kelvin degrees is are units who has more exactly precision than the Kelvin degrees, and because the gases they have a sensible chemical composition, the units from Kelvin degrees must be said that will be according for to obtain a constant values or average values for the gases. Always the temperature will be given in Kelvin degrees. Understood?
Yes. Okay, Mister.
Okay then. Well, that was the part A. Actually, that's why I labeled this one like a part A. And let's going to do it the part B. Part B. In the part B, the problem says, okay, if the gas is heated so that both the pressure and volume are double, what is the final temperature? Well, in this case, there is no constant factors. So we're going to say this is going to be a case of combined gases. Okay, this is going to be the sequence of the part B. What values do we have? Okay, in this situation, says the pressure and the volume are double. Okay, we're going to say the pressure P2, that will be equal twice the value of the pressure 1. Okay, but what's going to be the value for the volume? No idea. The only information that we got, the new volume will be twice the original volume because the problem says both elements will be double. And you know, the initial temperature is still doing by 300 Kelvin degrees, and we're looking for the second temperature. Okay, what we're going to do? One simple. Because this is the case, we have the formula already for trying to find out what will be the temperature too, right? You don't need to create the, well, actually, we have to do it by using the combined laws of gases. Remember, P1, B1 over T1 equals P2, B2 over T1. Well, sorry, already T2. Well, to solve for this equation, we had to do it the same performance. I mean, we're going to apply cross multiplication. P1, volume 1, T2, that will be equal P2, B2, T1. And because we are looking for the second temperature or the new temperature, temperature number 2 will be given by P2, volume 2, T1 over P1 and B1. This is going to be the new equation. So in simple merely words, the new temperature will be given by the pressure number 2 is twice the pressure number 1. So 2 times P1. The volume number 2 is twice the volume number 1. The temperature is 300 Kelvin degrees. Divided by what? The value from P1 and volume 1. As soon as you can see, this value from P1 and P1 can be canceled. And B1 with B1 can be canceled. For that reason, the only thing that we must do is multiply. 2 times 2, 4. 4 times 3, 12. So basically, the new temperature will be 1,200 Kelvin degrees. And this is going to be the solution set, at least for the first problem. Questions? Questions? ¿No hay preguntas?
No, mister.
Bueno. Did you copy that already? ¿Ya lo copiaron? Okay, let me know when you're finished. I'm going to give you a couple minutes to do it. By the way, can you hear my voice loud and clear? I guess.
Yes.
And you can read perfectly well the things written in the whiteboard. The two
Yes, as well.
problems. Okay, then. Excellent. Mhm. Por cierto, muchachos, ya el video de la mañana de las determinantes ya lo subí por el canal para cuando ustedes lo quieran ver, ¿verdad? Y este video también lo vamos a subir por el canal, así que no sean gachos. Denle like, suscríbanse y compartan. Tu compartir es mi sueldo. Estamos dando publicidad. Ahora sí, ¿puedo borrar o todavía no? Hello.
Sí, mister.
Va.
Sí.
Bueno, voy a borrar la parte B. Excelente. All right then. The second example. This is the problem number 32. An automobile tire is inflate with air, originally at 10 Celsius degrees. Okay, 10 Celsius degrees and normal atmospheric pressure. Remember when the problem says normal atmospheric pressure, this is the PNT or PST, right? That means the value of the pressure will be 1 atmosphere or 1.013 times 10 at the 5th power pascals. During the process, the air is compressed to 28% of its original volume, and the temperature is increased to 40%. Okay, so the question is, what is the pressure in pascals? Okay, let's going to do it in the part A. Again, part 8. In the part 8, we have the pressure number 1, that will be 1.013 times 10 at the 5th power pascals. Why? Because the problem says the pressure at the beginning is a normal atmospheric pressure. Pressure, that I mean PNT. Now that in original temperature is 10 Celsius degrees, you know, 10 Celsius degrees, remember the process. If you want to transform Celsius degrees into Kelvin, the only thing that we must do is add by 273. 273 plus 10 will be 283 Kelvin degrees. Continuing with the problem. During the process, the air is compressed to 28% of its original volume. Okay, what does that mean? That means the new volume that will be equal only the 28% of the original one. I mean, you must multiply 0.28 because we're passes the percentage into decimals. 28 times what? The original volume. For that reason, and the new temperature is increased to 40 degrees. Now the new temperature will be 40 degrees. If you add 40 plus 273, you know, that will be 313 Kelvin degrees. And they're asking for what will be the new value for the pressure in pascals. If you see the problem asking for the original value in pascals, no in the atmosphere. So there is no constant factors, okay? Because there's no constant factors, we're going to apply that combined level of gases. Remember, pressure 1, volume 1 over temperature 1, that will be equal to pressure 2, volume 2 over the new temperature, okay? This time, at the moment, going to solve for this equation will be easier for the last one because we are looking for P2. Well, simple. This quantity is divide, passes to multiply. This is multiply, passes to divide. It's simple, merely words. The pressure 1, volume 1, multiplied by the new temperature will be divided by the product between the first temperature multiplying by the second volume, and this is going to be the new value of the pressure. Okay, so basically the pressure 1, remember, 1.013 times 10 feet power pascals. The value from the volume 1, no idea. I don't know, you neither, and there's no way we can do it. Well, we can know what will be the new volume. So that's why we are using volume 1. What else? We have the new temperature. Remember, the new temperature in this case will be 313 Kelvin degrees. And this entire equation divided by the original temperature, 283 Kelvin degrees, multiplying by 0.28 times the value from the volume 1. And this is going to be the value for the new pressure. So what we're going to do, if you see Kelvin degrees, Kelvin degrees can be canceled with Kelvin degrees. Volume 1 with volume 1. And the answer will be given in pascals. And how are we going to operate this equation in your calculator? Let me show you one single example. Let me share the screen. Hold on. We have this beautiful freaking apps, calculator applications. Okay. Hold on. Share the screen again. And that's it. Can you see? I think you can see the calculator already, right? Yes or no? Hello?
Yes.
Okie dokie then. So we have to multiply that quantity. What we're going to do? Simple. We have the scientific notation.
Yes.
1.013 times 10 feet power, close parentheses, open parentheses, 313. Close parentheses, divided by, open double parentheses, okay, because the outside parentheses will overprotect the product between them. 283, close the first one, open again, 0.28, and close twice. Okay, as soon as you can see, we have this operation, equal button, and the answer will be 400,000. 400,000, 137.56 pascals. This is going to be the value from the new pressure. This is one way how you can do it. Another way to do it. Okay, simple. Push the fraction button. Okay. The over part, remember, open parentheses, 1.013 times 10, fifth power, close parentheses, open parentheses, 313, close parentheses, over, open double parentheses, and 283, close parentheses, open parentheses, 0.28, and close twice. Equal what? Oops, bye, algo que voy mal. Vamos a ver cómo que le hago, cómo que le hago, cómo le hago. Vamos a ver qué hice mal, qué hice mal, qué hice mal. Ah, ahí está, ¿qué se me pasó? Es que le hice muy adelantito el paréntesis. If you see, we got the same answer. 400,137.56 pascals. And this is going to be the answer for the first question, the part 8. Okay. Now let's see what we got in the part B. I'm going to erase this part of the whiteboard.
Mister,
Yep.
una pregunta, ¿de dónde
Sí.
sale el 283 y el 313?
Son las temperaturas Celsius convertidas a Kelvin.
¿Cómo
Recuerde
se
que
suman?
súmele 273. Al principio la temperatura original era 10. 10, súmele 273 y tiene 283. Y la nueva, aquí dice que son 85. 85 súmele 273 y le queda 313. ¿Estamos?
Ok, está
Dele.
bien.
¿Otra pregunta?
Solo eso.
Okay. Let's do it. The part B. Part B. Part B. The part B says, after the car is driving at high speed, the tire air's temperature rises. Ah, no sé si era la primera. Ah, no, la primera era con, perdone, la primera era 40. Perdone, no es con 85. Perdone, este 313, 40 más 313. Uy, 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 perdónenme. Hay un error aquí. Perdón. Mire, yo en lugar de 40, pues sumé con 85. Perdonen, perdonen, perdonen. Vamos a hacer esa pequeña corrección. A 40, no, 40 más 273. No, olvídelo, está bien, olvídelo, olvídelo. Olvídelo, está correcto. In the part B, this 313 Kelvin degrees is because we add 40 plus 273. Okay, in the part B, after the car is driving at high speed, the tire's air temperature rises to 85 degrees and the tire's interior volume increases by 2%. So the question is, what will be the new tire pressure? Okay, so in the part B, what will be the initial pressure? Okay. ¿Cuál será la presión número 1? Anyone? Hello. Obviamente la misma. Cuando se recuerde que estamos, la presión inicial es cuando empezaba todas las condiciones, una atmósfera. 1.013 times 10 feet power pascals. The original temperature, that will be 283 Kelvin degrees. The new temperature, we must add 85 plus 273. So the new temperature will be 358 Kelvin degrees. And what else? The problem says the new volume will increases by 2%. I mean, the second volume will be the value of the original volume plus the increment, 2%. We must multiply 0.02 times the value of the volume number 1. And we have one number, imaginary number, plus this one. So we can conclude the new volume will be given by 1.02 times the volume 1. Okay? This is going to be the equations. For that reason, we are looking for the new value from the pressure. Okay? As soon as you can see, and this problem, we have already the formula from the pressure number 2. Pressure number 2, that will be equal to P1, B1, T2 over T1 and B2. Okay, this is going to be the new value from the pressure. Now let's going to replace those values. I mean, the pressure number 2 will be equal to the pressure 1, 1.013 times 10 feet power pascals, multiplying by the volume 1, no idea, will be volume 1. The temperature number 2 will be 358. 358 Kelvin degrees. The entire equation divided by temperature 1, 283 Kelvin degrees, multiplied by what? The new volume. And remember that new volume will be 1.02 times the volume 1. And once again, you can perfectly cancel Kelvin with Kelvin, volume 1 and volume 1, and we're going to obtain the value of the pressure number 2. Let's do it again. Okay, share the screen. We have the calculator once again, okay? Well, if you wish, you can push the fraction button and start over again. Open parentheses, 1.013 times 10 feet power, close parentheses. Open parentheses, 358. Oh, 358. Close parentheses. Okay. Now divided by, open the parentheses twice, and we must multiply 283. Close parentheses, open parentheses, 1.02, and sorry, close parentheses twice, 1 and 2. As soon as you can see, push the enter button, and the answer will be 125,000 633.62 pascals. And this is going to be the solution set for the new pressure. I mean, in the part B conditions. Let me stop share the screen. And this is going to be the solution. Questions? Preguntas? Mis estimados aprendices. ¿Está todo claro? ¿Está todo azul?
Sí, mister.
Bueno, entonces, si no hay preguntas y está todo claro, todo azul, entonces nos vamos a ver el día lunes, si Dios así lo permite. Espero que lo pasen bien, cuídense mucho, Dios los bendiga, los guarde, los cuide. Ya saben, si les gustó el video, denle like, suscríbase, comparta. Su compartir es mi sueldo. Cuídense mucho, bendiciones muchachos. Bye bye. So long. Take care of yourself.
Bye, mister.
Bye. Adda sosta.